I'm going to give you guys about 5 minutes. This is on page 108 in your book. I want you to look at these 6 equations and without actually solving them. So looking at the structure, you're allowed to do some stuff to them, but I don't want final answers on any of them. Okay? So you're allowed to use rules and properties of algebra to move and manipulate numbers and variables to try to get these equations to look like one of the other equations there. I want you to group together any that you believe have the same solutions. I'm going to give you 5 minutes to work on this with a partner if you would like. And then we will go through these together. All right, I do want to start talking about these.
No, I'm not ready. I can't see. My glasses got delivered this morning.
They got delivered this morning?
Yes.
Yay!
But see, I was at school.
But that means you'll have them starting tomorrow and moving forward. Do you guys think that number 1 and number 2 would have the same answer?
Wait.
I feel like that answer different sign. No.
I'm sorry, you said something about different signs, but I didn't hear what you said at first. I liked what I was hearing.
I said maybe the same number but different sign.
Maybe the same number, but different signs. Why do you think that? I like that answer.
Because the x plus 3, there's an x plus 3 and an x minus 3, and then there's a negative 5x minus 4 and 5x plus 4.
So these are the same, and this is opposite from that. This one is opposite from that. So the guess here is same number but different signs. So not the same exact solution, correct?
I think it would be the same solution.
You think it would be the same solution?
I mean, I don't know because I didn't look through the problem, but looking at it,
See, this is why you just.
okay, well, let me talk to my teacher. Thank you. Back to what I was saying.
Woo!
Yeah.
Oh my gosh.
Okay, so you could like distribute it, right? You could do like minus x or 5x on both problems.
Minus x from 5x on both problems. I like that.
And then you get 4x, but blase blase. So then you would take the other one and you would plus 4x to 3. And then with the other one, you would get your answers. It's my bad.
No, that's okay. I like the way you reasoned through that.
Okay, well, you talk.
That was a great way to process through what's going on here. All right, so these are the first things that were explained. You would subtract x from both sides, right? And then from here, if you add 4 to both sides, you would get 7 equals 4x, right? What would we do over here on the other one? Subtract 4. Opposite operation, because we got to make it cancel, right? So I end up with negative 7 equals 4x. I didn't take either one of these to final solutions. Yeah. Would we have the same answer from these?
No.
How are you guys feeling about Cheyenne's thoughts?
Yeah.
Same numbers, but different signs, which means they'd be on opposite sides of 0 on the number line. So not the same solution.
Am I looking at
Curious. Right here, where we subtracted x from both sides, what property is that? We talked about this yesterday. What property? Yes. This is the subtraction property of equality. What do we call it right here where we added 4 to both sides? Yes, this is the addition property of equality. Yes, ma'am.
With the answer
Not necessarily, because I could solve it. Right now, when I say would they have the same solution, like if I feed the same input into them, would they have the same output? Or if I were to graph them, would these two lines cross in the same spot there? These two, like, because I've got technically two different lines here. These two lines would not cross at the same spot that these two lines would. Does that make sense? So far, nothing has the same solution, but we've only looked at two.
Are you serious?
Number 3, is there anything that I could do to that third equation to try to make it look like either of the first two? Like what Gianna did with the first two?
What did I do? Can I do it?
Yeah.
I tried it.
Walk me through a similar process for the third one that you did with the first two when you were trying to make them look the same.
Okay, the 2x plus 8. Right, so minus 2x.
Minus 2x on both sides, because first we need to get our variables together.
Right, then you get 3x.
8 equals 3x minus 3,
And then plus 3
plus 3 on both sides.
is 11.
From this point right here, without even taking it any further than this, can you tell by looking at it whether it would have the same solution with either of those? Not necessarily. However, if we take it one more step, can we see it then? What was the next step that you wanted to take?
After the 11 part? Or,
Before that. I just subtracted 2x from both sides. I'm behind you.
oh, 2x from both sides, and then you're going to subtract 3. I mean, add 3.
Add 3 to both sides. What's 8 plus 3? 11. Would this have the same solution as either of those? No. How do you know by looking at it?
I mean, I know it
We have 7 equals 4x for one of them, negative 7 equals 4x for another one, and then 11 equals 3x. What would have to be true if they were going to have the same answer? The 4x part would need to be the same, and the 7 would need to be the same. Or it would have to be multiples of those so that when I reduced it, I got the same thing. So it might not be 7 and 4, it might be 14 and 8. Or it could be 28 and 16. So that when I divide them, they would reduce down to the same number. So none of these three over here have the same solution. We still have 3 more to look at. What could I try with number 4 to make it look like 1, 2, or 3? Tell me some things that I could do with that. What could I do with number 4? You said I could do what with the 10x plus 6? No, I like what you were saying. Just repeat it. I didn't hear all of it.
You could reduce that part so it looks similar to number 3.
So that it looks similar to number 3. So when you say reduce it, what are you thinking of? What operation are you thinking of? Division. What should we divide by? 2. I can divide both of these by 2. If I do it to one side, have to do it to the other side. So I'd have to divide everybody over here by 2. What property would that be?
Division property of equality.
Yes. Division property of equality. Anytime we do stuff to both sides, it's a property of equality. And then you just tell me what operation you're doing to both sides. What is 10x divided by 2?
5x.
5x. What is 6 divided by 2? 3. It's equal to, what would this give me? X minus 4. Five x plus 3, x minus 4. That kind of looks like some of the ones on the other side. Which ones does it remind you most of?
The negative one.
The negative one? So it reminds you of this one?
Yeah.
Is there anything that I could do to number 4 now that I've divided everything by 2 to make it look exactly like this one?
I don't really know what you did. I mean, you could solve it.
We could solve it, but we're trying not to solve it.
You know, like, you can't do the X thing.
Can we substitute?
We could try substitution. Why don't we try using some of those properties of equality again? I heard that it looks like number 2, but on number 2 it's x minus 3, not x minus 4, and it's 5x plus 4, not 5x plus 3. How could I get the 3 and the 4 to switch sides so that it looked more like that one? Subtract it. So I'm going to move that up here so that I can do some operations with it here. If I subtracted 3 from both sides, and at the same time I added 4 to both sides, I'm not trying to combine anything, I'm just trying to move things to the other side of the equal sign. Here it's going to cancel. What would that give me over on the left?
1.
What would I have on the left?
9x.
Almost. This doesn't have an x with it, so I can't combine it together. What pieces do I still have over on the left?
5x.
5x. And then what? Is there an operation there? Plus 4. Can't combine it anymore, but I can write down what I still have left, right? I still have a 5. The 5 is being multiplied to the x. I still have that plus 4. Can't combine it at all beyond that. What about on the other side?
Subtract.
Yep.
So that would be 1.
So these two are going to cancel here. Negative 4 plus 4. What do I still have left on the right-hand side?
X.
X. Anything else? Minus 3. So we still have this piece, and I still have this piece. What does that look like?
Like second one.
Looks like the second one. What's different about it, though?
It's like on the other side.
Does that matter?
No.
No. As long as the order of my variables, my operations, and my constants, my numbers are the same, it doesn't matter which side of the equal sign it's on. So number 2 and number 4 have the same solution. Same solution.
So did you just like move things around? You didn't do anything?
Yep, that's exactly what I did. I used properties of addition and subtraction, not to combine anything together, just to move which side of the equation it was on. Does that make sense? Okay. It's not the only way that we can check to see if they would have the same answer. What could I do to number 5? Because number 5 looks an awful lot like number 4. So I'm curious if it has the same answer as anything else that we've already done. What could we try with number 5? Dante, any thoughts? On number 5, the one with a V next to it. What could I try with that to make it look like any of the other equations that have come before it? Yes, ma'am. We can reduce this one as well. What property is that? Division property of equality. This one we can reduce as well. I'm going to move that right here because I'm running out of space. So I'd get 5x minus 4 equals x plus 3. What does that remind us of? Which one? Number 1.
So why'd you pick divide again? Why'd you divide again?
That was the suggestion.
But if they all can go into 2, right?
Yep, 2 can go into all of them. So this looks like 1. That means it would have the same solution as number 1. It doesn't just kind of look like number 1. It has the same variables, it has the same coefficients, it has the same constants. Those are numbers without variables with them. And it has the same operations in the same order. 5x minus 4, 5x minus 4. X plus 3, x plus 3. It doesn't matter what side of the equal sign it's on. Does anybody by any chance remember what that property is called? Not necessarily, when I just want to flip sides of the equal sign, but other than that, everything else stays exactly the same. That's absolutely correct. That is the reflexive property. That's one that you should have learned about in geometry. I always remember it in a way that has me saying the wrong word, but it's close enough that I get it right. Because when you look in the mirror, who do you see? You see your reflection, you see yourself. It's the same on both sides. Same thing here, reflexive property. Number 6 looks gross. What's ugly looking about number 6? Fractions and decimals. What's the biggest denominator? 10. Let's multiply everything through by 10 so that we can get rid of all of those fractions and decimals. What property would that be? Multiplication property of equality, yes. Do it to one side, do it to the other side. So that means I need to distribute. And I'm going to just bring that down here. What is 10 times 0.3? 3. So I have 3 plus x, because x divided by 10 times 10, my 10s will cancel. Over on the other side, I need to distribute that 10 as well. What's half of 10? So I have 5x minus 4. Does that look like any of the other equations? Looks like the first one. I see the 5x minus 4, 5x minus 4. That's on the correct side of the equal sign, right? But number 1 has x plus 3, and this one has 3 plus x. Is that a problem? No. That's okay. That's equivalent. Does anybody remember what that property is? Close. We'd be staying just on one side. Things that allow me to just switch the order like that and keep the sign in the middle the same, that's the commutative property. Commutative property of addition, it doesn't work with subtraction. Because if I had x minus 3, that's different than 3 minus x. But with addition, I can switch it around. Because if I add 5 and 3, that's the same as 3 and 5. Multiplication works the same way. It doesn't matter what order I put the numbers in. So this one looks like 1. So ones that have the same solution, number 1, number 5, and number 6 have the same solution. I'm going to write this down up at the top here. Same solutions. One and 5 and 6. Did any others have the same solution? 2 and 4. And poor 3 didn't match anybody. I want to keep kind of practicing with these ideas. If you look over on page 109, there's different equation pairs. We're just going to look at 2 at a time and see if we can use any of those properties to take the one that's on the left and make it look exactly like the one that's on the right. We're going to try to determine whether or not they are equivalent. So I'm starting with this equation right here, and I want to try to make it look like this one. Do you see anything that I could do to the first equation to try to make it look like the second equation? Yes, sir.
You can add the 2x to the 5x.
I can add the 2x to both sides. What property is that?
Addition.
Addition property of equality. What would the output be? What would it give me after I do that addition? I'd have 7 plus 7x equals 3. And then I have negative 2x plus 2x. What happens right here? Cancels out. So I have nothing there. Does that look exactly like this?
Yeah.
Yes. So I would say that these are equivalent. These are equivalent equations. Means they would have the same answer. I don't even need to get to where I solve it all the way out to know that they would have the same answer, because I made one look exactly like the other. So from here, the steps for solving for both of these would be exactly the same. You guys okay with that? All right. Let's look at the next one. Number 2. I want to take this one over here, and I want to try to make it look exactly like this one. What could I do to the first one? What type of thing would I be allowed to do? I can distribute the 3. That would be the distributive property. So that would give me 3x minus 12 equals 15. Do either side of the equal sign match either side of the other one? The 15s match. Does the other side match? Does the left side match? Okay. Back to the drawing board. Instead of distributing, which means multiplying, right? What else could I try? I could try dividing. That'd be the division property of equality. Oh, I don't know why I wrote a 5 down there. Should be a 3. My apologies. I think I was looking at that 15 and got carried away. So that would cancel out here. What would I have on the left-hand side then?
Wait.
On the left?
X minus 4. Sorry, I thought.
That's okay.
I got my left and right mixed up.
X minus 4. What would I have on the right side then? 5. So now I've made the left sides match, right? Are the right sides the same? Would these have the same answer then? No. These two are not equivalent. They would not have the same answer. Two more. We're going to do number 3 together, and then I'm going to set you guys loose on number 4. Number 3. What's something I could try to make this left-hand equation look just like the one on the right?
Times by
So take this one and times it by x?
the second one.
I want to mess with this one right here. It's okay. I understand why you're saying that.
No.
Square root it.
Oh.
Okay, we can try that. What would that leave me with?
X plus
X equals square root of 6x. Can I simplify that any further?
Can't you do?
Not really. Because the square root of 6 isn't a whole number, right?
So you can't have I.
I would be if I had a negative under there. Do either sides match? The x's match, so I made the left-hand side match. But the right-hand side doesn't match. Is there anything else I can try? Divide by x. We could try that. What would that give me? X equals 6. Looks like we might have found it, right? Question. Do we know what x is? Is there anything that would be on the bottom of a fraction that would cause that fraction to fall apart? 0. X can't be 0. Do we know that x is not 0? We don't know this. That means I can't do this. I would have to know that x is not 0 in order to be allowed to divide by it. If I don't know that for sure, I can't, because x is an unknown value.
But isn't x by itself just 1?
It's 1x. X could take on any value, or I could have it represent apples or dollars or any number of things, but it's some value that I don't know. Yep. Do you guys think these two would have the exact same solutions? If I could divide both sides by x, I could get it there. But I can't do that because I don't know for sure that x is not 0. So I would say not equivalent here. Question. X equals 6 has how many solutions? 1. The only thing that would make that true is if I substituted a 6 in the place of x, right? 6 equals 6. Yes. Any other number in the place of x? No. How many solutions does x squared equals 6x have? 2. How do you know? Because of the squared. If my two equations have a different number of solutions, they can't be equivalent. If one has more solutions than the other, then they can't have all the same answers in common. Does that make sense? Not all solutions the same. They might have some solutions that are the same. The one that works for x equals 6 might work in the other one. Would it work? If I put 6 in the place of x here, would I get something back that's true? What is 6 squared? What is 6 times 6? 36. So does that work here? Yes, it does. So they have one solution in common. There's another possible value for x that would make this true. Can anybody think of what it might be? There's something else that if I took it and multiplied it by itself, it would give me the same answer as taking 6 and multiplying it by that number. Any ideas? There's one number that I can multiply by anything, and I always know I'm going to get the same output every time. Not 1. That would mean that nothing changes. I like that answer, but I would have to know what number I'm multiplying 1 by to know what my output would be. There's only one number that I know of that it doesn't matter what I'm multiplying it to. All I have to know is my number, and I know for sure what the answer would be. 0. 6 times 0 is? 0. 100 times 0 is? 0. 1,000,000 times 0 is 0. If I do 0 squared, that's 0 times 0, what would the output be? 0. 6 times 0 is 0. Those are those two solutions. Does 0 work in the place of x over here with this one? 0 equals 6, not true. That's why they're not equivalent. They have one solution in common, but not both of them. I want you guys to look at number 4, the last one on the page. I want you to determine whether or not these are equivalent. Can you use any of those properties of algebra to make the one on the left look exactly like the one on the right?
What page is it on?
109. At least stay with me. I know you can't write everything down. I want you to try to manipulate or work with the one that's on the left to make it look like the one that's on the right.
Oh, that was easy.
Can you think of any operation that would allow you to get rid of the fraction here? Because this one doesn't have a fraction there.
I'm done.
Fractions mean what operation is happening? Division. How could you go about undoing division? Multiplication. And if you do it to one side,
You have to do it to the other.
have to do it to the other side. Try that. See if you can make it look like the other one.
Well, I finished in 5 seconds.
Beautiful. So equivalent or not? Equivalent or not?
Yes.
Yes. You
Oh,
want to write
yeah.
that down. Yep. Are these equivalent?
Yes.
Tell me what operation I could do. Multiplication. What would I multiply by?
X minus 5.
X minus 5. We'd multiply here. Rules of algebra. Which property am I using here? Multiplication, property of equality. When I talk about the rules of algebra, those are our properties. Do it to one side, got to do the exact same thing to the other side. So that's going to cancel. I'd be left with a 1. What would I have on the other side?
10. And the x minus 5.
And then times x minus 5. These are identical. So that means they are equivalent. Equivalent equations have the same solution. How many solutions would this have? 1. Have the same solution. Multiplication property of equality here. Beautiful. No homework. So you guys need to catch up on any homeworks that you still have missing. Tomorrow, most of you guys are going to be out of the building due to PSATs. Only sophomores and juniors will be here in the building.
Juniors here?
Sophomores and juniors will be in the building. Seniors are supposed to be scheduling college visits. So I won't see any of my seniors. Yes, ma'am.
I'm the IP.
Sleep in. There is a very short assignment on Canvas. There's a very short assignment on Canvas to practice these skills. All right? Please complete that. Those of you that will still be in this room tomorrow, because you will be here for the PSAT, we're not doing anything. So you can work on that. You can ask me questions. You can sleep. It does not matter. After 4 hours of testing, I'm not going to try to teach anything at all.
Do you have to be here?